Think about this. If your database is several terabytes in size, do you really want to back up the entire database every single day? Probably not. And that's where RMAN backup type become important. In this video, we are going to look at 4 key concepts: full backup, level 0 incremental backups, level 1 differential backups, and level 1 cumulative backups. We also see how these choices affect backup size, storage, backup time, and recovery. Choosing a backup type isn't just a technical decision, it directly affects your backup environment. A full backup can take more time and consume more storage because you are backing up all the used database blocks. Incremental backup can reduce that amount by focusing on changes, but there is a trade-off. As DBAs, we need to balance backup duration and storage consumption with recovery speed and the business requirements of the organization. So the goal isn't simply to create the smallest backup possible. The goal is to have a backup strategy that gives us the right balance between backup and recovery. Let's start with the simplest one, a full backup. A full RMAN backup copies all used blocks in the database. That gives us a complete backup and makes the recovery foundation relatively straightforward. The downside is that it can require more storage and take longer compared with incremental backups. For example, the RMAN command is simple: backup database. And when the database is running in archive log mode, the backup can be performed while the database remains online. So when does a full backup make sense? One common situation is when you are taking an initial backup of the database. It's also useful before major upgrades or patching activities, where having a complete recovery point is important. For small databases, a full backup may also be perfectly practical because storage and backup time might not be the major concern. And sometimes simplicity itself is the reason to choose a full backup. You have a complete backup and your recovery strategy is easier to understand. Now let's change the approach. Instead of backing up everything again, an incremental backup focuses on changed blocks. This can significantly reduce backup size and backup time, especially for large databases where only a portion of the data changes regularly. RMAN uses SCN or system change numbers to determine what has changed since the applicable previous backup. The important thing to remember is that an incremental backup needs a baseline, and that is where level 0 comes in. Level 0 is the baseline for RMAN incremental backup strategy. It contains all the used blocks needed to establish that baseline. So although a level 0 can look very similar to a full backup in terms of the amount of data backed up, there is an important difference. Level 0 is part of the incremental backup strategy. Level 1 backups can use that level 0 as their baseline. Think of level 0 as the starting point of an incremental backup chain. After establishing our level 0 baseline, we can move to level 1. Level 1 backup focuses on blocks that have changed. They are generally smaller than the level 0 blocks, and RMAN gives us 2 approaches for level 1 backups. We have differential and cumulative. The key difference is what each one uses as its reference point. Once you understand that difference, the rest becomes much easier. First, let's look at differential. A level 1 differential backup is the default level 1 behavior. It backs up blocks that have changed since the most recent applicable incremental backup. So if we have a level 0 on Sunday and a differential level 1 on Monday, Monday captures the changes since that level 0. Then Tuesday, differential captures the changes since the most recent applicable incremental backup. The advantage is smaller individual backups. The trade-off is that recovery may require more incremental backups to be applied. Now let's look at cumulative. A level 1 cumulative backup looks back to the most recent level 0. So instead of only capturing changes since the previous level 1, it captures all changes since that level 0. That means the cumulative backup can become larger as more changes accumulate. But there is a benefit. During recovery, fewer incremental backups may need to be applied. So we are essentially trading larger backups for potential simpler and faster recovery. Here is the key comparison. Differential backups are generally small and can be faster to create, but they may require more recovery steps. Cumulative backups are generally larger because they include changes since the level 0, but they can reduce the number of incremental backups needed during recovery. So if backup size and backup time are major concerns, differential may be attractive. If recovery speed is the bigger priority, cumulative may be preferable. Neither option is automatically better. The right choice depends on the backup and the recovery requirements. Let's put everything together. A full backup contains all used blocks, but it isn't part of an incremental chain. A level 0 also contains the baseline data, but it established the foundation for level 1's incremental backup. A level 1 differential contains changes since the most recent applicable incremental backup, and the level 1 cumulative contains changes since the level 0 backup. Understanding these differences is important because your backup type directly affects how your recovery process will work. Here's a simple example. On Sunday, we take a level 0 backup. Then from Monday through Saturday, we take level 1 backups. This means we are not repeatedly copying the entire database every day. We are establishing a baseline and then capturing changes throughout the week. The exact schedule will depend on the organization requirements, backup window, storage capacity, and recovery needs. But the basic idea is simply establish a baseline, then capture changes. Now we get to the part that really matters, recovery. In a simple recovery scenario, we first restore the required level 0 backup, then we apply the required level 1 backups. After that, archive redo can be applied to move the database towards the required recovery point. Finally, we recover and open the database. This is why we shouldn't design a backup strategy based only on how easy it is to create backups. We also need to think about how those backups will actually be used during recovery. As a DBA, protecting the backup chain is critical. We need to protect the level 0 baseline, the level 1 backups, the control files, and the archive redo required for recovery. We also need to monitor backup jobs and investigate failures. But there's one point I really want you to remember. A successful backup job does not automatically mean you have a successful recovery strategy. You need to test your restores regularly and verify that your recovery objective can actually be achieved. So let's quickly recap. Full means a complete backup of the used data blocks. Level 0 is the baseline for an incremental strategy. Differential captures changes since the most recent applicable incremental backup. Cumulative captures changes since the level 0. And smaller backups don't always mean faster recovery. The real goal is a backup strategy that can successfully recover your database where you need it. If this video helped you understand RMAN backup type, like the video, subscribe for more Oracle DBA content, and let me know in the comments which RMAN topics you'd like to see next.